Welcome, advanced topic students, to 1.3 Notes, Applications of Linear Equations. If you haven't figured it out already, I love the ocean and love marine life, and that's why this whale shark is drawn here. This section is all about translating mathematics into words, into kind of real-world situations. I know word problems is a trigger for a lot of people, but we're going to try to break it down and make it a little bit more bearable for each and every one of you, okay? So let's go ahead and jump right into it. I guess we're going to go with different shades of blue here. Let's start with the dark blue and work our way down. Addition, verbal expressions. The sum of a number and 7. What does that mean? Sum of a number. Well, if we're talking about sum, we're talking about addition. A number, we don't know what it is, so we'll call it x, and then 7. So x plus 7 would be that translation. That's what we're doing here. We're taking words and putting them into math. So if you're going to see an expression in math or an equals or an equation with an equal sign in math, we would see it in this way. We would not see it with the words. 6 more than a number. I think I'm going to just cycle through some variables here. We could use x for all of these, but I'm just going to say y plus 6. So that's a number plus 6. 3 plus a number. So we could have 3 plus, and we could call it call it m. 24 added to a number. These are all ways of saying the same thing. So 24 added to a number, we'll call it n. And then a number increased by 5. That's another way to say it. So we can say c plus 5. And then the sum of two numbers. Now here we have two variables because we don't know what they are. So we'll just call it x plus y. Now, one thing you'll notice here, sometimes I had the variable first, sometimes I had the number first. It's not super important to do that or to distinguish which one's which. I just kind of base it off of the language, but all these mean the same thing when you flip them. So if we wrote m plus 3 instead of 3 plus m, it's the same thing, okay? It's the same value. Now, subtraction you got to be careful with. So we're going to be careful with subtraction. We're going to change the blue. 2 less than a number. So 2 less than a number. Now, this is, so if we're talking about 2 less than a number, we're talking about, for example, if we had 10, 2 less than that number would be 8. How do we go from 10 to 8? We did 10 minus 8. So 2 less than a number. We're going to take that number. Let's go ahead and use p. And then we subtract 2. So 10 minus 2 got us 8. 2 less than a number, p minus 2. 2 less a number. Now, this is a little bit different. If it doesn't say that then we're just taking 2 and we're lessing a number. We're subtracting 2 minus q. This one's probably the tough one that people forget. Okay, so be careful with this one and this one, trying to distinguish those two. 12 minus a number. Pretty clear here. We're just going to do 12 minus a number. We'll call it r. A number decreased by 12. This one's pretty self-explanatory. We're going to take 12 and we're going to decrease it. Whoops. No, we're taking a number, x, and we're decreasing it by 12. A number subtracted from 10. Same deal here. We're taking y and we're subtracting 10 from it. 10 subtracted from a number. Same thing. We're taking 10 and we're subtracting it from z. So z minus 10, it's the same thing. The difference of two numbers. This one, for example, a minus b, that is the difference. Anytime you have subtraction, that is the difference. Now, I'm just going to say this. I should have said this at the beginning. If you don't want to hear my explanations, you just want to copy down the notes, fast forward until this is done. It'll save you some time. 16 times a number. We're talking about multiplication now. Let's switch colors. So we have 16 times a number. We'll call this 16. I don't want to use E. 16, whatever. We'll just call it X. A number multiplied by 6. 6y. 2/3 of a number. 2/3 z. Or, this is what I prefer, 2z over 3. It's the same thing. Okay? I like putting the variables in the top though. 3/4 as much as a number. Well, we can call this 3/4 a. Twice a number. 2 times a number. Well, that's the same thing as 2 times b, or any number, any variable. Triple a number. Well, that's 3c. The product of two numbers. Well, we could call this m times n. m and n. Last one, here's our last color, last shade of blue. We're on division. The quotient, quotient means divide. The quotient of, this blue isn't very good, is it? Just use a different one. Here we go. The quotient means divide. The quotient of 8 and a number. So here we have 8 divided by x. 8 and a number. The quotient of that number goes on top. A number divided by 13. Well, that's pretty obvious. We're just going to take a number, let's call it y, and we'll divide it by 13. You could also do y. I don't know why this guy has a tail and the other one doesn't. Divided by 13. A ratio of two numbers to have like x over y. The quotient of two numbers, same deal, but we'll call this a over b. So hopefully this is helpful. You learned something here. Let me erase this. There's your chart. Pause and copy that down. And moving on. Let's apply it. During the 2013 season, MLB pitchers Yu Darvish and Max Scherzer had a total of 517 strikeouts. Darvish had 37 more than Scherzer. How many did each pitcher have? First thing you should probably do is define your variables. So number one, we need to define variables. So here we're going to say D is our Darvish strikeouts. And we'll say, Y is U, Darvish, never mind. We'll do M is our Max. Now I might as well make it S. But I don't like using S because it looks like a 5, so we'll keep it Max. M is our Scherzer strikeouts. Okay, now that we know our variables, now we have to find the value. Find value in terms of the other. What do I mean by that? Well, notice how we don't know how many each has. That's our whole goal, is to find out how many strikeouts each pitcher has. We do know certain things. We know that D plus M, the strikeouts for both, need a total up to 517. That's something that we know. Darvish, here's something else we know. Darvish had 37 more than Scherzer. So what we need to do is, this is finding the value in terms of the other. It gives us something in comparison to the other. So we know that Darvish, if we take his strikeouts, we have Scherzer's strikeouts, and he needs 37 more in order to equal Darvish. So Darvish is kind of the man here. He had more than Max did. Oops, sorry. M's my variable there. So Max needed to add 37 to his. That's more than, I think we had that up there, more than, in order to equal Darvish. So that's the second piece of information that we have. Now, we don't want an equation in two variables, so what we're going to do here is we're going to substitute. This is like system of equations here. We're going to substitute this value of D in for this equation. So now we're going to say M plus 37, this is our substitution here, plus M equals 517. Now it's just a matter of solving this equation. So we're going to take, first we'll combine like terms. We have M, so we're going to get 2M, obviously, plus 37 equals 517. This is just a two-step equation at this point. So we have 517 minus 37, because we need to subtract 37 from both sides, minus 37, minus 37. Okay, we get 480 equals 2M. Divide by 2, we get M equals 240 strikeouts. Now that we have this, okay, we'll make it this color, blue, that we solved it. We need to find Darvish. In order to do it for Darvish, we know we can plug it in there. So we know this is equal to 240 plus 37 to equal D, and that is clearly 277. And we have our answer for the number of strikeouts each one of these pitchers had, okay? So again, define variables, find values in terms of the other, and number 3, solve for each variable. Okay, Thomas invested $40,000. He put part of the money in an account paying 2% interest, oof, rough, and the rest into an account paying 3%, also rough. Really poor choice on his part. So we're going to, let me get to that in a second. The total income was $1,020. How much money did he invest in each account? Super relevant problem here, especially if you go into banking or finance, which makes a lot of money. So there's some incentive there for you. But let's come up with 2 accounts. So we have account, that's supposed to be a C, account A, and then we have account B. Let's get organized. Okay, we could call this one variable A and then variable B, just so you feel a little bit better about yourself. And then we have 2% and then 3%. Now, do we know how much money goes into each account? No, that's the whole point. But we do know that the money in A, oops, sorry, I need to define the variables. This is the 2% account. We're going to say that A equals the money in account A, and we'll say B is the money in account B. That's what we're trying to find. So let's make our variables what we're trying to find. We do know that the money needs to add up to $40,000. So we're going to say that A plus B equals $40,000. Anytime you have 2 variables, as we do here, see how A is different than B? Anytime you have 2 variables equals 2 equations. So we need to, number 1, define variables. Done. Number 2, find value in terms of the other. So we're trying to find the value of one in terms of the other. So what else do we know? Well, we know that the total income was $1,020. That's our other secret. Okay, so how do we do this? Well, we need to find one in terms of the other, and notice how we don't have any variable by itself yet. So let's get the A by itself. So we're going to say A equals 40,000 minus B. Okay, so there's a variable by itself. This is in terms of the other one, but we need a second equation. This still counts as one equation, so we need to write an equation using the information given, which is 2% interest and 3% interest. Well, how do we do that? Well, if this were one big account, we would take the money and we would multiply by the percent interest, and that would tell us the income. Okay? So this is kind of like our master formula. We're going to multiply by the percentage to find our income. So we know our income equals 1,020, but the problem is we have money in 2 different accounts. We have 2 different percentages. We have percentage from account A. This is, hold on, how do I write this? We have 2 different percentages. We have an A percentage and a B percentage. So we have 2 different percentages. So how do we account for that? Well, we know that equals $1,020, and we know account A has 40,000 minus B dollars in it. So 40,000 minus B is going to be our A account. Now, what do we multiply this by to find out what is the income from account A? We need to multiply this by 0.02%. That's how you convert 2% becomes 0.02. Okay? This will tell us the amount of income from account A. When you add it to account B, it's going to equal 1,020 when we're all done. Okay? Notice how I got rid of the A variable. Where did the A variable go? It disappeared, right? We now have that B in place. We now have that B in place of A. Well, this is very good for us because now we know that we can just take the amount from account B, multiply it by its percent, 0.03, and that will give us our total amount, okay? This is how we find the income from account B, 3%. This is how we find the income from that. This is the income from account A because this is A right here. That's our money from account A times 0.02. That's how we found it from account A. And this will add up to our total sum, which is 1,020. So now we just need to, whoops, that's supposed to be a highlighter. Now we just need to combine like terms, distribute, do all that stuff, solve, and we're good. This is why multi-step equations are super important. So we're going to distribute here to both these terms. So we're going to first have to do 40,000 times 0.2. So we have 40,000, I'm doing this on my calculator, times 0.02. And I get 800. So I have 800 minus 0.02b plus 0.03b equals 1,020. Okay, I need to combine like terms. So I do 0.03 minus 0.02, that's going to give me 0.01b plus 800 equals 1,020. I need to subtract 1,020 from, or 800 from 1,020, and I get 0.01b equals 220. And now I need to divide by 0.01 to get my amount in account B, divide by 0.01. When you divide by a decimal, it gets bigger. That's a very common misconception. A lot of people are confused by this, okay? But anyway, we get $22,000 in account B. So account B has $22,000 in it. Now, we could go ahead and substitute this into B, into our first equation, this one in green, to find what we need in account A. Very simply, it's going to be $18,000 once we do that subtraction. Let me just show you for thoroughness sake. A equals 40,000 minus 22,000, and we get 18,000 for A. So that's how you do it. This is a super relevant problem. I know it may seem confusing. This is going to be the building block of everything that we're going to be doing in advanced topics. So really make sure that you break this down and understand it. Thanks for watching. Looking forward to seeing you next time.